Alright, let's examine what we have here. Radius circle, I don't know why that came out so weird looking, but 15 meters is our radius. Now, the apparent weight, that's force normal, is half of the true weight. True weight's force gravity. So this is kind of like what we did before. So we're going over the top of a roller coaster. Force gravity's down, force normal is up, and our positive direction is going to be down because that's the direction of the center of the circle. So over to F, all the sum of the forces equals mv squared when divided by the radius. I have two forces, and they said my force normal now is half of my force gravity just by what they told me over here. So force normal is going to be negative because it's pointed away from there, away from the center of the circle. So it's 0.5 times force gravity plus force gravity equals mv squared over r. So if I have a negative half of gravity and a positive 1, I subtract a half off and I get 0.5 force of gravity equals mv squared over r. Sorry, I missed this too. We're solving for how fast. Normally that's what we're going to solve for because velocity and radius are the only things that really matter in most of these. So force of gravity, wrong color. Force of gravity, so it's 0.5 mg equals mv squared over r. Let's get v all by itself, multiply both sides by r, and divide both sides by m. And I get v squared equals r times 0.5 of gravity. We'll square root both sides, and I need a little room here. I'm writing too big. I don't know what's wrong with me today. Alright, let's go back to this. So v equals r times 0.5, half of gravity basically, and we'll square root our answer. Oh, I should have written in what r was. 15 meters times 0.5 times 9.8 meters per second squared. And to the calculator we go. Square root answer, and I get a velocity of about 8.5. I'll round that up to 8.6 meters per second. Woo woo? Woo woo.